So you ever see those like amazing AI videos online, the ones that look totally professional, and you kind of think, wow, okay, that's cool. But yeah, my computer could never do that. You're not alone there.
Oh, yeah,
See what I mean?
definitely. Oh, it feels like you need some kind of supercomputer, right? A
Yeah.
massive GPU setup.
Exactly. Like you hit this wall, this VRAM wall for creators, for tech people, the really cool AI video stuff. It's always seemed to need, well, huge amounts of VRAM, like server farm level stuff, hasn't it?
It's a very real frustration. I
Yeah,
mean, these models are incredible, but yeah, the hardware demands have kept them out of reach for most people with, normal computers.
totally. That VRAM barrier has been a huge hurdle stopping a lot of creative ideas. But what if I told you that wall is kind of starting to crumble?
Oh,
Yeah, today we're doing a deep dive into something really interesting with the Wan2.2 model, specifically an optimized version. And this version just drastically lowers that barrier. It lets you run it locally on your own machine with as little as 8 gigabytes of VRAM.
wow. Okay. Yeah, that's not just a small change. That's potentially huge. It means opening up some really powerful video tools to way more people.
Exactly. So our source material today, it's straight from the horse's mouth, basically. Excerpts from the Wan2.2 GitHub repository.
Ah, the actual code and instructions. Good stuff.
Yeah, loads of technical details,
Mhm.
practical steps. And our mission today is to unpack how they did this. How is this even possible? What went into it? And crucially, what does this mean for you? The creator, the tech enthusiast who probably doesn't have a room full of GPUs,
Right.
will look at the specific steps, the clever ideas behind it all that make this kind of power accessible right on your own machine. Okay, so to really get why this 8GB thing is such a big deal, we first need to understand like the scale of the problem. Why do these top-tier video AI models usually need so much VRAM? What are we typically talking about?
Yeah, that's the perfect place to start. Because understanding the original challenge makes this solution way more impressive. You see, these big generative models, especially for video, they're just incredibly complex. They have to store just a massive number of parameters.
Parameters being like the model's brain, its learned knowledge.
Exactly. That plus all the calculations happening while it's generating the video,
Mhm.
all that stuff needs to live in the GPU's memory, the VRAM, so it can be accessed super fast.
And if you don't have enough space.
Then boom, out of
Yeah.
memory errors. The model just can't run. It falls over.
Uh,
And our source material really highlights this. It says for the standard kind of off-the-shelf 1.2.2 T2V A14B model, running it on a single GPU without these special tweaks, you'd usually need at least 80 gigabytes of VRAM.
80. Okay, wow. 80. That's way beyond what most people have in their gaming PC or laptop. Puts it in perspective.
Totally. It shows just how high that barrier really was.
So before we get into the VRAM magic, tell us a bit about Wan 2.2 itself. What is it? What makes it this open and advanced, large-scale video generative model worth all this optimization effort?
Right. So WAN 2.2 is a pretty significant step up, building on their earlier WAN 2.1 model.
Mm.
And what makes it stand out and why this optimization is so cool comes down to a few key things from the source. First off, it uses something called a mixture of experts architecture, or MO.
Mixture of exos,
Okay,
yeah.
it's clever. Instead of one giant model trying to do everything at once, it kind of splits the job up, specifically the denoising part. It uses specialized expert models for different stages. Like the A14B version we're talking about uses two experts. There's a high noise expert that figures out the broad strokes, the layout early on.
Okay, like the basic structure.
Exactly. And then a low noise expert comes in later to handle all the fine details, make it look sharp.
Ah, like specialists. One for the blueprint, one for the finishing touches. Does that help with memory?
It does, indirectly at first. So each expert might have, say, 14 billion parameters. That means the total model size is huge, like 27 billion parameters.
Oh,
And here's the smart part. Only one expert, roughly 14 billion parameters, is actually active at any given moment during generation.
okay. So the total size is massive, but the amount you need right now is kept stable.
Precisely. It lets the model be more capable overall, but keeps the active memory usage, the inference cost, from ballooning. It's smart parameter management. And that helps pave the way for the later VRAM savings.
Makes total sense. Handle big complexity without needing all of it in RAM at once. Smart. What else is special about Wan 2.2?
Another big thing is its focus on cinematic level aesthetics. This isn't just about making any video, it's about making good-looking video.
Yeah.
They trained it on really carefully chosen data with detailed labels for things like, lighting, camera angles, composition, contrast, color.
So you can actually control the style more.
Exactly. For you, the user, it means you can push beyond just generic AI output. You can actually try to dial in a specific mood, a professional look. It gives you more kind of director-level control.
That's huge, especially if you want polished content, not just weird AI experiments.
Yeah.
Control the visual story. Nice.
Yeah, definitely. And then there's its ability with complex motion generation. Compared to the previous version, 1.2.1, they fed this one way more data. Like the source says, 65.6% more images and a whopping 83.2% more videos.
Wow, that's a lot more training material.
It is. And that massive increase really helps the model understand motion, how things should move, different styles better. It leads to more realistic, more dynamic movement in the videos, makes it super versatile.
Okay, so it's powerful, it's smart about parameters, and it's focused on quality visuals and motion. Definitely sounds like a model worth getting into more hands. Which brings us to the main event. This is where it gets really exciting. Our source lays out specific steps, how to run this beast on just 8 GB of VRAM. This feels like a real game changer. Can you walk us through those steps? How did they actually make this 8 GB breakthrough happen?
Absolutely. This is the core of it, right?
Yeah.
The source gives 4 clear sequential steps. You got to do them in order. First step, pretty basic, download the model. You use the Hugging Face client, which is a common tool for this stuff.
Right,
To
standard.
grab the Wan2.2 T2V 814B model files and save them locally. The source even gives the command. Hugging Face clan download Wan2.2 T2V A14B local door 1.2.2 T2V A14B.
Okay, so step one.
Yeah.
Get the files onto your computer. Simple enough. What's next?
Step 2. This is where a major VRAM optimization kicks in. You need to convert the model to bfloat 16.
Convert.bfloat16. Okay.
Yeah, there's a Python script provided, convert-safe-tensors.py. You run this, and it specifically targets the high-noise model and low-noise model parts.
Oh, yeah.
And safe tensors. That's just a safe way they package these models. Stops weird code execution, keeps things consistent.
Gotcha. Safe packaging. But the key is converting to bfloat16. Why? What's special about that format?
So the source puts it really plainly. It says this conversion is done, quote, to fit one block of the model into 8 GB VRAM.
Ah, okay. That's the goal.
Exactly. bfloat16 is a floating point format, like how computers store numbers with decimals. But it uses less precision than the standard 32-bit floats. By using bfloat16, you basically cut the memory needed for many parts of the model in half.
Half the memory. Okay, that's a huge saving right there. Less precision, but maybe good enough?
Apparently so. For this purpose,
Yeah.
it dramatically shrinks the VRAM footprint without completely tanking the quality. It's a really clever trade-off to make it fit on smaller GPUs.
Right, like putting the model on a VRAM diet. Makes it leaner for consumer cards. That's step 2. What's 3?
Step 3 is to optimize the files. Critically, you do this after the bfloat16 conversion. You run another script, optimizefiles.py, and what this does is split those safe tensors files up by modules.
Splitting them up. Why?
Well, it seems to be about loading things more efficiently. By breaking the model into smaller modular chunks, the system probably only loads the specific pieces it needs into VRAM at any one time.
Ah, instead of trying to cram the whole thing in at once.
Exactly. It doesn't try to fit everything in your precious HEB simultaneously. It loads modules as needed, another layer of smart memory management.
Very clever. Break it down, load on demand. Okay, that's 3 steps. Download, convert, optimize. What's the last step?
The fun part. Step 4, generate video.
Finally.
Yeah. Once you've done the prep, you run the main script, generate local.py. You tell it the task, T2V A14B, the size you want, like 128/720 for 720p, where your prepared model files are, seek EPTT, and then your prompt.
The creative part.
Exactly. And the example prompt in the source is pretty fun. Prompt. 2 anthropomorphic cats in comfy boxing gear and bright gloves fight intensely on a spotlighted stage.
Okay, I need to see that video. 2 cats boxing. That really shows the kind of imaginative stuff you can do.
Right. It tells the script. Use the text-to-video model, make a 720p video, use these optimized files, and bring those boxing cats to life.
Amazing. So, okay, you follow those 4 steps. You've got it running. What's the reality? What are the trade-offs, the catches? It can't be exactly like running it on 80 GB, right?
No, definitely not. There are practical limits, and the source is upfront about them. The biggest one is a frame limit.
Okay. How limited?
When you're running on just 8 GB, it says generated frames are limited to 21, 25, to ensure it fits within the memory.
21 to 25 frames, so about 1 second of video at standard frame rates.
Yeah, roughly. Maybe a tiny bit more depending on the exact frame rate used. So you're not making long sequences this way. It's geared towards shorter clips.
Which makes sense. It's a compromise to get it running at all, but still, 25 frames is enough for like a cool social media clip, an animated logo, testing an idea.
Absolutely. It's a very usable length for many applications. It's a fantastic entry point.
Definitely. Does the source mention performance? Like, how long does it take to make those 25 frames?
It does. They actually tested it on a specific laptop. A Helios Predator 300 with an NVIDIA 3070 Ti 8GB card. Pretty common gaming laptop GPU.
Okay, yeah, relatable hardware.
And for 25 frames, they clocked it at 83.40 seconds per iteration.
So a bit under a minute and a half to generate that 1 second-ish clip.
Yeah. Which, honestly, for generating high-def video from text on a laptop GPU, that's pretty darn impressive.
It really is. We're not talking hours here.
Not at all. And what's even cooler, they pushed it further. They tested on just 6 GB of VRAM.
Wow, even less.
Yeah. And there, it could manage 17 frames, taking about 66 seconds per iteration. So it even scales down reasonably well to slightly lower spec cards.
That's incredible. It really democratizes access. You don't need that top-tier $1,000 plus card or renting time on cloud servers anymore. Not for trying this out.
Exactly. That's the whole point. This isn't just some, technical exercise. It's about making these powerful AI tools accessible. Getting this level of video generation running on hardware many people already have or could realistically afford. That's a massive step. It lowers those barriers we talked about, financial, technical.
And that is why this matters so much to you listening right now. Think about what you could do with this. You could create those short, really eye-catching videos for social media. You could bring personal art projects to life in a new way, or just play around, explore what this AI can do without spending a fortune. Imagine making a quick dynamic intro for your stream, or an animated visual for a presentation, or just turning a funny idea into a short clip.
Right on your own machine.
Yeah, running it locally gives you way more control. Privacy, too, for your creative work, and speed. You can tweak a prompt, generate, see it in like 90 seconds, think, not quite, tweak it again.
That rapid iteration is key for creativity. You're not waiting ages or watching cloud credits burn. You can just experiment.
It fosters that kind of playful, experimental approach, empowers individuals, small studios, to try things out way faster. It really does feel like a shift, doesn't it?
It really does. For so long, these kinds of tools felt locked away in big labs or behind huge paywalls.
Yeah. So wrapping up, today we've seen how Wan2.2, this really advanced video model with its smart MOE design and focus on cinematic quality, can actually be run on hardware you might already own.
Thanks to those key steps. Converting parts to bfloat 16 to save memory.
Right.
Optimizing the files to load them in chunks.
Uh-huh.
And accepting a reasonable frame limit to make it all fit within that 8GB VRAM budget.
It unlocks really powerful video generation capabilities for so many more people.
It moves high-end AI video from being this exclusive thing to something potentially on your desktop.
And this Wan2.2 optimization, it's more than just clever coding. It feels like a glimpse into the future, right? A future where the most powerful AI isn't stuck in data centers, but becomes a standard tool for everyday creators, like Photoshop or a video editor is today. So the final thought for you is, when this kind of powerful video generation is right there on your own machine, easily accessible, what creative boundaries are you going to push? What stories will you tell? We'll see you next time on The Deep Dive.